Today we'll be doing the integral from 0 to e of x times the square root of e to the x dx. And to start off, we could visualize what this area actually looks like. So it's something like this, and going from 0 to e. So this is the area we're looking for. And to do this integral, we will use integration by parts. So we could let u equal x, then du will be dx. We could let dv equal the square root of e to the x, but that tells us that v equals the integral of the square root of e to the x dx. So we have to find this integral first. So the integral of the square root of e to the x dx, to evaluate this integral, we could use a substitution. So we could let a equal e to the x. Solving for x, we have the natural log of a equals x. Taking the derivative on both sides, we have dx is 1 over a dA. And now this integral would turn into the square root of a over a dA, but we could rationalize the numerator and denominator, and we'll get a divided by a times the square root of a dA. The a's will cancel, and we're left with the integral of 1 over a to the 1/2 power dA, or the integral of a to the minus 1/2 power dA. So we have to evaluate this integral. So this is going to be a to the negative 1/2 plus 1 divided by negative 1/2 plus 1, which will be a to the 1/2 divided by 1/2, but this simplifies to 2a to the 1/2, which is equal to 2 square root of a, but we said a equals e to the x. So the integral of the square root of e to the x dx is 2 square root of e to the x. So our original goal was the integral from 0 to e of x times the square root of e to the x dx. And we said that u equals x, so that du equals dx. And we set dv equal to the square root of e to the x, so that v equals the integral of the square root of e to the x dx. But we said this is going to be 2 times the square root of e to the x. So our goal integral, the integral from 0 to e of x times the square root of e to the x dx, will be u times v minus the integral of v to square root of e to the x du dx. So this is equal to 2x square root of e to the x minus 2 integral square root of e to the x dx. And the integral of the square root of e to the x, we said, was 2 times the square root of e to the x. So this is equal to 2x square root of e to the x minus 2 times the square root of e to the x, which is equal to 2x square root of e to the x minus 4 square root of e to the x. We had to evaluate at the endpoints from 0 to e. So this is going to equal 2 times e square root e to the e power minus 4 square root e to the e. So this is f of b minus 2 times 0 square root e to the 0 minus 4 square root of e to the 0 power. And 0 times anything will go to 0. And we're left with 2e square root of e to the e minus 4 square root of e to the e. E to the 0 power is 1, and the square root of 1 is 1. And a negative times a negative will make a positive 4. So plus 4. So now we could say therefore the integral from 0 to e of x times the square root of e to the x dx will be precisely the square root of e to the e, 2e minus 4 plus 4. And this is the final result. Thank you very much for watching.